Greetings. Okay, so as promised, this is part two of my PC using a television. Uh, doesn't matter if it's OLED or regular TVs or not, um, as a computer monitor for PC gaming. Um, so uh, we're going to go over a couple of things today. We're also going to touch upon a couple of things I went over in my last video. Um, Part one was about 40 minutes long. I'm going to try to keep this one down a little shorter. I'll try to organize myself. Once again, I'm not used to doing this. I'm trying to get a little better. And without further ado, let's hop into it. Okay, so first things first. When it comes into retrospect of when it comes to using your television as a PC monitor, there are a lot of things that people don't realize. That there's a lot of features and cool things you can do that will extend the life of your television long, long past whenever new technologies come out and that try to hit you with buzzwords and say you need to upgrade like 8K or whatever. Like I said in my previous video, before I moved on to the televisions I'm using now, which is a 77-inch LG C9 OLED and a 55-inch LG B9 OLED. Before I moved on to these monitors, I was using two, I was using multiple, all around the house, 1080p Samsung plasma screen televisions. Okay, all the way till up until 2020. I bought the TVs in 2012 and 2013. That's when they were manufactured and produced, and I used them all the way up to 2020. That is a very long time, and I was able to get all this life out of my televisions because I was able to do awesome things such as downsampling from higher resolutions, um, which my television was then able to display to give me much better picture quality. All right. We're going to touch upon a lot of that today. Okay. So in my last video, I showed you how to use Crew Custom Resolution Utility in order to take your native 4K display and turn it into a native 1080p or 1440p display to free up bandwidth to be able to do all sorts of neat little things. Today, we are at native 4K today. We're at native 4K today for this video, and I am going to show you how my native 4K setup is. All right, so let's go into the Nvidia control panel. And sorry, it was already open. All right, so in the NVIDIA control panel, as you see this weird stuff that says scaling resolution, and you see stuff that says custom resolutions, and you see, of course, uh, my native resolution, 3840 by 2160. Now, originally, there's going to be a resolution up higher than this called 4096 by 2160. That is the cinema resolution for 4K, and that is a resolution you want to delete out of your EDID. You want to delete that information, that resolution completely out using Crew. The reason for this, and I don't think I'd ever really talked about why I hate that resolution so much, is because that resolution will cause interference when you use NVIDIA DSR. NVIDIA DSR works off off the highest available resolution in your display. It's supposed to work off your native resolution, but NVIDIA, it might be a glitch or whatever, but instead it's working off the highest available resolution. And even though the native resolution of your display is 3840 by 2160, it's going to work off the highest available resolution, which will be 4096 by 2160. So when you use DSR, when you use DSR, the resolutions it's going to create are going to look wrong. It's going to create really weird resolutions that do not exactly match up with the aspect ratio of your display. Um, and that's because of that 4096 by 2160 resolution. So you got to use Crew and you got to delete that resolution out wherever you find it in the EDID. And then you will be just left with regular 3840 by 2160. And then when you use NVIDIA DSR, it will work properly. TCL, I had a television from them that I returned because because this was before I realized I could delete 4096 by 2160 out of the EDID. I was trying to use DSR and it was going based off that weird resolution, and next thing you know, my tops and bottoms of my screen was cut off. Like I couldn't see my taskbar, I couldn't see nothing up here. It was all cut off because the television was using overscan. And it was undefeatable overscan. There was no way to get rid of the overscan, and that was because of that dumbass 4096 by 2160 resolution. So delete that resolution out with crew. I explained how to delete resolutions out in my last video. All right. So uh, moving on. So let me explain how all this is set up for in my NVIDIA control panel when I decide to play at my native resolution, which is 3840 by 2160. Okay. Um, as you can see here, I created some custom resolutions. I didn't get a chance to go over that in my last video, how to properly create custom resolutions in NVIDIA control panel. So I'm going to show you now. So if you go here, and once you select your native resolution, you go here to customize and you hit customize, and this is going to open up this new menu here. And then as you can see, I already got a ton of resolutions in here. 2688 by 1512 at 120. All of these are custom resolutions I created when I made my display a native 1440p display. So these are all going based off 1440p. All right. So these are all unchecked because I don't need these interfering in my games when I'm playing games. If I want to play at 4K, I want to do 4K 60, not 4K 120. I want to do native 4K 60, not downscaled to downsampled 3840 by 2160 at 120 hertz. Anyway, so yeah, you select this resolution here, you hit create custom resolution, and then from here, you don't have to fool with anything down here. But just only two boxes you need to worry about is this one and this one. And then from here, you just go ahead and just type in what resolution you want, hit a test, and it's either going to work or it's not. Like I explained in my last video, custom resolutions is different from DSR because custom resolutions goes entirely off the capabilities of your HDMI port on your graphics card, the cable that you're using, and the HDMI port on your television. All right. So because it's actually whatever resolution you put in here, it's going to physically send that actual resolution to the display. So it's not downsampling. It's just going to send that native resolution straight to the display. And then it's up to your display's scaler chip, depending on how good it is, to display that image. All right. So I created, as you can see on the side, I created several resolutions above 4K, 4224 by 2376. And if you're wondering how did I come to these resolutions, there's a really handy website you can go to that shows you the full true list of 16 by 9 resolutions going all the way up to 8K. All right. So that list is located right here. It's a website called potcoop.com. You just do a Google search for list of true 16 by 9 resolutions. And here we go. This nice guy managed to create a full list of 16 by 9 resolutions going all the way up to 4K. You could read and tell you how he came up with these and how you can calculate it yourself. But the only thing you need to worry about is any resolution that's in green is a 16 by 9 resolution. So if you type any of these resolutions into your custom resolutions here, the horizontal and vertical lines, and hit test, 9 times out of 10, you're going to get an image. Okay. And like I said, you just scroll down the list, and then look, he tells you this is the official resolution for 720p. Then you scroll down some more, and then this is the official resolution for 1080p. Scroll down some more, and eventually you're going to get to WQHD, 2560 by 1440. Go some more. And like I said, anything, as long as it's highlighted in green and you select yes, you're good to go. Oh, special side note, whatever graphics card you're using, these resolutions are actually tied to, believe it or not, the amount of CUDA cores that are inside your graphics cards is directly tied to a resolution on this list. So it's like a recommended resolution. So for example, if you have a 1080 Ti, your 1080 Ti has 3584 CUDA cores. What do you know? 3584 by 2016. It may say, oh, this is a 4K card. Not exactly. The 1080 Ti wasn't exactly a 4K card because the Because if it did, the CUDA core count it would have had would be 3840 by 2160. The 1080 Ti only had 3584 CUDA cores. Okay, it would have had now the Titan um, did have 3840 CUDA cores, so that one was truly meant for 4K. Anyway, you scroll down some more, and it'll show you 5K, 5120 by 2880. Scroll down some more, and eventually you'll hit, I guess we'll call this 6K. You know, this is the first time you hit like a 6 in green. Scroll down some more, and you'll hit a 7, which is like, I guess, the first time we hit a 7 in green. I guess you can call this 7K. And then you scroll down some more, and eventually you'll hit 8K, which is 7680 by 4320. All right, this guy really went out of his way on this and created this list. But here you go. This is the full list of 16 by 9 resolutions. I like to work millions of pixels at a time. Um, so, for example, what I mean by that is like, let's go to 1080p here, right here. Okay. So 1080p, when you look at the resolution for 1080p, that's 1920 by 1080. Okay. That's a math problem. So if you take out your calculator and you do the math on that, you do 1920 times 1080, and you get 2,073,600 pixels. Tiny little dots, tiny little building blocks that make up your image on your display. All right. So that's 1440p is 2560 times 1440. And what do you know? That's 3 million pixels. And if you notice, that's kind of how I create my custom resolutions. I go 1 million pixels at a time. So 1080p is 2 million, 1440p, 3 million, you know, and then I go to 4 million and 5 million and 6 million and 7 million and 8 million. And I go up like that. And the reason why I do millions at a time is that way I can have granular control in my video games of how much performance hit I'm taking. Because when you use custom resolutions or DSR, when you downsample from a higher resolution down to your native resolution, it's using the same physical impact as if you're playing at that resolution. So if you're on a 1080p display and you're downsampling from 4K, your graphics card is going to experience the same performance impact as if you were playing at native 4K. No joke. So keep that in mind. All right. Especially when you do stuff like 8K and 5K, your graphics card, you got to have a really high-end graphics card to be able to game at those resolutions comfortably. All right. So yeah. So this also will help you when it comes to buying a television and some other helpful tips, because 1920 by 1080. All right. In case you're wondering where they got 4K from, that's this number, the number of pixels in 1080p times 4. That's 4K. That's the resolution for 4K. If you can literally do the math, you can go 3840 by 2160 in a calculator, and it will give you this exact number of pixels. So what's 8K? You do, once again, 2,073,600. So you do 2,073,600 times 8. And that's 8K. You know what I'm saying? So that's where he coming up with these names like 4K and 8K. They just take 1080p and they times it by the number they want to hit. You know what I'm saying? So that's why 1440p is kind of called, like, I think 2K or something like that. I don't know. Anyway, but yeah, that's 8K, 16 million pixels. That's a lot of pixels on the screen, a lot of detail, the building blocks of the digital world. Okay. Anyway, so that's where you go to get your list of custom resolutions that you can use to input in here. Any resolution that's highlighted in green, you can input it in here to create you a nice custom resolution for yourself. And you, of course, if your TV can support it, you can try to, bump up the hertz. Once again, you're either going to get a black screen and it's not going to work, or it's, you're going to get a picture and it works. So it's worth giving it a shot. All right. So in case you're wondering if you're an LG B9, C9, E9, or CX owner, the maximum amount of resolution you'll be able to go on this is 7680 by 4320. I mean, I don't know. You probably can go higher. I never tried. I never tried because this was the highest resolution on that list on that website just now. So I never tried to go above this. But out of my current graphics card, I have a 2080 Ti. Out of the maximum amount of bandwidth I could support out of this card is only going to allow me to do 7680 by 4320 8K resolution at 30 hertz. I cannot do 8K at 60 hertz out of this graphics card. I can only do custom resolutions up to 8K at 30 hertz. This resolution as well, let's call this 6K, 30 hertz. 5K on the other hand, 60 hertz. You know, I can do 5K no problem at 60 hertz. Okay. Um, and what's even a cooler is that I can do 5K at 60 hertz at YCVCR 422, 12-bit color, RGB, limited. I can do HDR basically at 5K at 60 hertz uh, with custom resolutions. Um, yeah, I would turn on HDR right now, but once again, uh, Nvidia does not like me recording at this. It may crash out. It may work, but everything's gonna look overblown, blown, and my recording. I don't know how it's gonna work out. But yeah. So yeah, you can do 5K resolution at 60 hertz. Uh, at with HDR. You just have to change your output color format. All right. Um, so yeah, this is going to be a little quick sidetrack. In case you guys are wondering what RGB and this YCBCR 444 and 422 and 420 is, you can go look it up online for a much better explanation. Because I know I'm telling you this wrong, but this is what all this crap means. Okay, so first let's explain RGB: red, green, blue. All right, on your television. All right, unless you're using an OLED television, on your television, the pixels on your TV are made up of three colors: red, green, and blue, RGB. All right. OLED, on the other hand, they couldn't have their pixels made up of RGB. They had to make their pixels made up of WRGB, white, or red, green, and blue. It was because with OLED technology, they could not. The blue pixel apparently kept failing. It would burn out than the other colors. The blue part of the pixel would burn out faster than the other colors. So they had to come up with this white pixel, and that's how we got OLED televisions today. They'd spent millions and probably even billions of dollars on the issue trying to figure out how they can get RG, to just how do we can get it to work properly, but they just couldn't. They just kept on the organic materials that the TV is made out of. The blue portion just kept on burning out before the others, so they had to come up with this other solution. Anyway, I digress. That is what your TV is made of red, green, and blue. Each pixel is made up of red, green, and blue. So whenever you play video games or watch movies, um, let's talk about video games. Whenever you play video games, they're made up in RGB, and that is the end result. It's going to be displayed on your TV as RGB. All right. So ideally, you want to use RGB limited or full. Doesn't matter. Um, Ideally, you want to use RGB full, but I'll explain the difference between that later. If you're on a PC monitor, you want to use RGB full. If you're on a television, you want to use RGB limited. Even if your television can support full, you still want to use limited. And I'm going to explain why. Uh, yeah, all video games are made in RGB, red, green, and blue pixels. So when that image is shot off that disc into your computer or into your game console, it's then hit through that HDMI cable as RGB, and then hits the television as RGB, and then it's displayed on the TV through the pixels as RGB. Your uh, These other formats are meant for movies, okay? And this is because of bandwidth issues, all right? So the movie industry, has been around for decades, centuries now, feels like, and there wasn't enough bandwidth to send this RGB signal to get to your display, which ends up always going to be RGB anyway. They had to cut down on some of the information. So how they use that, they use compression. All right. So YCBCR is just another way of representing RGB. Okay, so YZBCR 444 is basically just the movie standard way of representing RGB. Okay, but what they can do with YCBCR, they can compress it. They can compress the last two bits of information, the 4 and the 4, to 2 and 2 or 2 and 0. Now, you can look up online, they'll tell you exactly what these numbers mean, what all this means. But long story short, right now, if you only have an HDMI 2.0 graphics card or 2.0 television or whatever, if you want to get HDR to work, you can't send HDR through regular RGB, because the bandwidth is too big. You have to switch over to the movie standard of that, and you have to use compression, okay, to save space so you can get it to. So then once it hits your television turns this signal back to RGB and displays it. All right. So yeah, which is why the output dynamic range is always in limited uh, for when you use YCBCR. When you use RGB, you can do limited or full, but once again, since all movies and television shows are shot in this, and this is in limited, uh, and once again, there's an explanation of what limited is. Long story short, there's so many different shades of white, black, and white. Um, the deepest black is 0, and the whitest white is 255. Okay, well, that's in RGB full. But since, due to compression or whatever, and with this, using YCBCR, this stuff, it has to be, they have to limit it slightly. Okay. So in televisions, the lowest is, I think the lowest black is like 25 or 20 or something like that. And then the highest, the whitest white is 233. Okay. So it's not the full spectrum. Okay. But as long as you set your HDMI black level on your television side, oh, here it is. The full is 255, limited is 16 to 235. All right, I was wrong, but there we go. As long as you have this, when you're using RGB limited or YCBCR limited, or if you're using YCBCR, your television will take care of it for you. You won't have to change a thing. Actually, you will. Or if you're on an OLED, you will have to set it to low. If you're using limited, set your television to low. Set your shit to low. Your HDMI black level on your TV side to low. If you're using full, you have to set it to high. Your HDMI black level to high or normal. Samsung calls it normal. Okay. Anyway, I already explained this in my last video. Holy shit, I'm getting sidetracked. It's going to be a 40-minute video again. Yeah, so let's move on. Anyway, I can use, basically, if you're using HDR, in order to get HDR to work, you have to do YCBCR 422 or 420, and then you can access 10 or 12 bits. Thanks to the HDMI 2.1 port on its television, on LG OLEDs 2019 and 2020 televisions, you can do 12-bit color at YCBCR 422. On regular 2.0 televisions, you only be forced to do 10-bit at 422. And then if you go to 420, you might get access to 12-bit. All right. If not, it's just going to keep kicking you out. Okay, so that's done. So let's leave this at, I'm recording at 4K, so let me just leave it at the native resolution of 4K. All right, so now let's move on to this. Scaling resolution. So I had somebody ask me a question about this. They were like, oh, how does playing at 1080p look like when you're playing at native 4K? So if your TV's in native 4K mode, you didn't use crew, you just left it at native 4K. How does 1080p and 1440p look? And the answer is it looks totally fine. And I'm going to explain how it works. So in the NVIDIA control panel and manage 3D settings, you can go here to something called image sharpening. And if you select image sharpening, they have off and on. On basically gains you access to these controls. And they have GPU scaling. Now this is the feature you really care about. When you select this, it will tell you select the GPU use. I'm sorry, Jesus, I wish it would explain. All right, here we go. Turn on image sharpening on to increase the sharpness of your application. Use sharpen to adjust the level of sharpness. Ignore film grain to reduce over sharpening applications that use film grain. It still didn't explain what this is. All right, so GPU scaling is this. When you turn this on, and this is if you have a RTX graphics card, so a 20 series graphics card. If you have a 1080 series graphics card and you're playing on a 4K display, you're only gonna get access to 1080p. Yeah. Anyway, so this, when you select this, it's going to create several resolutions. New resolutions are going to appear over here in this change resolution tab. These new resolutions are going to appear 3264 by 1836, 2880 by 1620, 2560 by 1440. Even though that's already going to be in the television, this is a special one. And then finally 1920 by 1080. All right, even though this is in your TV, this is a special one. All right. And what these resolutions do, they're also going to appear twice. They're going to appear like over here. A couple of them will appear over here as well. Anything that says, here's a tip, anything that says 4K, 2K, that is your TV's way of telling you that, yo, these resolutions are all going to be upscaled back to 4K, to the native, okay? If you, now, see how this one just says 1080p? That means if you select this one, that means it's going to display this raw resolution as is. But anything that says 4K, 2K is basically the television's way of letting you know, yo, we're going to upscale this back to 4K the best way we can, all right? So that's basically what these are. These special resolutions that Nvidia gives you are special resolutions, fine-tuned, I guess you can say, and tailored to be upscaled back to native 4K, all right? So you just basically play the game, you just turn on your favorite video game, and you select any of these resolutions that on this list right here from within the game, and then it is going to upscale those resolutions back to native 4K for you. Now, to make those resolutions look even better, you can try to fool around with sharpening and ignore film grain and stuff like that. So basically, this is AMD has this feature as well. Anything AMD does, Nvidia finally does right after, or vice versa. They copy off each other. What this feature does, this basically adds a post-processing. It's a I forgot what version of sharpening this is. This is basically a low-level, in-depth special sharpening filter. I don't even want to say if I can call it a filter, but basically it's specifically trained to make the game look sharper and make it appear like it's playing at a higher resolution than what it is. All right, and then ignore film grain is basically in video games on PC. You have different option settings you can turn on the games, and one of them is film grain. I hate film grain. I turn that shit off. Why in the world would you defeat, 20, 30, 40, 50, 60, 70, 80, 100 years of goddamn television cinematography by adding in film grain in games? Anyway, if you turn the sharpening filter up to maximum, you're going to see these fuzzy beads all over your screen. That's because the game might have film grain in there, and that's what's being amplified. Well, if you adjust this slider, it will reduce that or negate it. You know what I'm saying? So I just like to run them both at the same time. I just like to max them out both at the same time. Now, I don't use this often because you can just actually hit Alt and F3, and if GeForce Experience of the game is compatible with it, it will allow you to use to adjust these sliders from within the game. But if you adjust them in the NVIDIA control panel, when you set this, it's going to stick like that, and that's it. You won't be able to adjust this when let's say you're playing a game. Let's say you have this set at this and you go play a game. You won't be able to Alt Tab out of the game and just change this and turn it off if you don't like the look of the game. It's going to stay like that till you exit the damn game. So it's easier but if you hit Alt F3 when you're in the game, you could pull up this same exact feature called Nvidia Ansel, I think it is, or something, and you can turn these on and adjust them at the fly and delete the filter out if you don't like it. It's pretty cool. It's pretty neat. All right. So yeah. So that's that. Okay. So what else can I talk to you about? All right. So here's some other information that I got for you guys. Types of HDMI cables. Okay. Now you can Google all this yourself as usual, and I'm not going to go super in depth, but I'm going to basically give you my experience on HDMI cables and what they could do. And HDMI.org is a great website that can tell you all you need to know about HDMI cables and which ones you need for your job. But I'm gonna put it to you like this: if you're using a 1080p television, even right now in 2020, um, or if you're using a 4K television, the only HDMI cable you need is just a high speed HDMI cable. Okay? If it says, ignore this, this is wrong. If it tells you 1080p, 4K 30 hertz, 3D, that's a lie. It could do 4K 60 hertz. It could do a lot of stuff. You just need a high speed HDMI cable. Okay? I used high speed HDMI cables for years. Um, I forgot when they came out, but I have a fuck ton of high speed HDMI cables. And remember, on the cable itself, on the actual sleeve of the cable itself, printed in white, it will tell you what type of cable it is. Um, but that's what it is. Those aren't just like name. These names of these cables aren't actually just some bullshit names to come up with to try to make them sound cool. No, this is an actual specification. So it'll say high speed. It'll say standard HDMI cable. These are the cables that come shipped with Nintendo Switches. So standard HDMI cables only work for 1080i or 720p. These are the cables that literally come shipped with Nintendo Switches because the Nintendo Switch can't play at a high resolution. So I guess Nintendo must have got a fuck ton of them on discount, and they ship these with the Nintendo with the Nintendo Switch. Do not use a Nintendo Switch HDMI cable for anything else but that Nintendo Switch. Because if you do, you are going to not get a picture at all, or the picture you will get is going to be a garbled mess. Okay, because it's only meant for low resolutions. Especially if you're trying to do 4K or something with it, don't do that. All right. So mark the cable that comes with your Nintendo Switch with a marker, so people will know not to use this cable for anything but that damn Nintendo Switch. All right. Now, high speed HDMI cable. Ignore the auto. I don't care about that. High speed HDMI cable. This shit is everywhere. You will find these all over the place. You will trip and fall on these. This is going to be by far the most common HDMI cable you're going to see all over the place. All right. These cables will give you 4K 60. If you got a 1080p television, you're downsampling from any resolution you want, these will work just fine. If you're doing 4K 60 or whatever, this cable will work just fine. I was just using this cable before I upgraded to the ultra high speed HDMI cables, and they were working just fine for all my needs. So this is the only cable you're going to need if you're doing 4K at 60 hertz gaming on your PlayStation, your Xbox, whatever. This is all you need. You'll find these all over the place. Next, high-speed HDMI cable with Ethernet. Now, apparently you need to use this cable when you're using stuff like ARC. Um, when you use an ARC, audio return channel. Now, I was able to use ARC just fine with the high speed HDMI cable, but apparently with Ethernet is meant for that audio return channel. That's for audio return channel. All right, so you can and LG literally says it on their website. They're like, oh, if you're having problems using ARC, make sure your cable says high speed HDMI cable with Ethernet. All right. Um, then there's the next step up, premium high-speed HDMI cable with Ethernet. Now these are supposed to basically tell you, this is supposed to give you guaranteed 4K 60, and it's supposed to be able to be used with EARC, Enhanced Audio Return Channel, where you can get fully uncompressed audio to send through your television or whatnot to your receiver if your receiver supports EARC. You have to use a premium, it will say premium on the wire, high speed HDMI cable with Ethernet. All right. And then finally, the cream of the crop. This is for if you have an LG OLED 2019 or 2020 television. These are the cables you have to go buy. All right. The ultra high speed HDMI cable. It will say it physically on the wire. It will have this label here certifying that it is. it will say on the wire ultra high speed HDMI cable. These cables will support uncompressed 8K 60 and 4K 120. And this supports the full HDMI 2.1 bandwidth of 48 gigabytes per second. And it's backwards compatible with existing HDMI devices, of course. So this is the cable you need to go get if you have an LG OLED 2019 or 2020 television that has HDMI 2.1, of course. This is what the fuck you need. In fact, if you get any television that supports HDMI 2.1, this is the cable you need to be using. You need to be using this cable, all right? And all of these should come with Ethernet. They don't say with Ethernet on the side, but it's going to come with Ethernet. That's just how they're going to come going forward. And that's to use EARC, Enhanced Audio Return Channel, okay? So, yeah, if you're using a 1080, so quick recap. If you're just hooking up a game console straight to your 4K television, high-speed HDMI cable, that's all you need. If you're just hooking a regular old Xbox, PS4 Pro, or your PC to your 4K television, all you need is, or your 1080p television, all you need is a high-speed HDMI cable. It will say it on the cable. If you're doing a home theater system or a sound bar and you need audio return channel, it needs to say high-speed HDMI cable with Ethernet. All right. Then finally, if you're going to do EARC, Enhanced Audio Return Channel, then it needs to have premium high-speed HDMI cable with Ethernet. And then finally, if you got an HDMI 2.1 graphics card and television or whatever, you need this bad boy, ultra high-speed HDMI cable. Okay, so just wanted to show y'all that to give y'all some information. I don't know if y'all know about this, but it was new to me. But apparently, on those cables, when it says ultra and premium and high speed, that isn't some shits or giggles bullshit, marketing. That's a real specification telling you what this thing is capable of doing. All right. You can read up on it. I'm not going to go any further than that, so I'm going to exit those tabs out. Once again, this is just parroting off my previous video. The LG 2019 and 2020 OLEDs, EARC does not work properly. It's not working properly, and LG is aware of the issue, and LG will be introducing a update in the second quarter of 2020. I heard June. We'll see when the hell this comes out. But it's really fucked up because the 2019 televisions have been out a whole year. The 2020 TVs have just gotten out, and they don't support linear PCM multi-channel. Like I have a Sony STR DH790 receiver, and I'm supposed to be able to do 7.1 audio, the whole shebang, EARC and everything. It's set up properly. It has the latest firmware. It will not work. It's not working with this TV at all. My TV, my PC only sees, once again, I'm just doing this to show you guys. My PC only sees, no, okay, that just hit no, I don't care. My PC only sees, for supported formats, it only sees 2 channels. It only sees stereo. And for compressed formats, it don't see any out of this television. It sees, shows the correct sampling rates, but it's supposed to, since I'm using EARC right now. I'm using EARC right now. My TV is set up for EARC. My receiver's EARC is turned on and enabled. The number of channels it's supposed to see is 8. It's supposed to see my full surround sound system, but it doesn't. All it sees is 2. And I explained in my previous video, it doesn't even see, compressed formats for Dolby Digital, Dolby Atmos, because I'm at native 4K 60, and apparently that's too much damn bandwidth to get this to work properly. So I have to, I explained that in my first video, how to solve that issue. But anyway, yeah. So we're gonna be waiting on an update from LG to fix this issue. All right, we just gotta wait. So this is an issue that I've been having. Other people have been having it. If you plug your PC into your television and you set your television to EARC, your receiver to EARC, and turn on pass through and everything, so the signal, audio signal can pass through your television to your receiver, so you can get your wonderful surround sound, uncompressed surround sound. It's not going to work because we're waiting on an update from LG. Okay, so just wanted to talk about that and parrot that from my last video. All right, so yeah. Now the last part of my video we're going to talk about is creating custom DSR resolutions. Okay, so as you can see right here, we're using custom resolutions, Nvidia Custom Resolutions, and we're able to go up to 4K at 30 hertz. Okay, but if you use Nvidia DSR, you can go up to 8K at 60 hertz just fine, because as I explained how DSR works, it is simply rendering everything internally on the graphics card side at a higher resolution and then downsampling that back to the native resolution of your display through advanced filtering, and then it sends that completed compiled image out through your graphics card's HDMI port, through the HDMI cable, and then finally to the TV itself. Okay, and your TV sees it as a 4K image, but your TV doesn't know, hey, this is a 4K image that's actually been downsampled from 8K, so it looks unbelievably crisp and clean. Okay, so if you're playing it on a native 4K set, there's really literally no work you have to do. You just go to DSR factors here, and if you've properly gotten rid of that resolution 4096 by 2160 by using Crew, like I told you guys, when you turn on DSR here, I can do this right now, it won't mess up the video. When I select all these factors and hit 30%, that's why I like it, because I'm weird, and hit apply, screen's gonna flicker, and then now when you go back here to change resolution, what do you know? Dynamic super resolution. It's going to create a bunch of new resolutions, 16:9 resolutions here. And one of those resolutions is going to be, where the hell is it? Here it is. 7680 by 4320, 8K. 8K, and look, it's 8K at 60 hertz. I can actually hit apply on this, and I don't think it's going to mess up. Oh God, everything's green. We're going to go back. Nope, we're going to go back. I forgot. I forgot this. I forgot this was like this. It's gonna work if I set this back to RGB, because I'm at 12-bit color. It does not. That's another thing I want to tell you guys. When you do 8K, even if you're doing custom resolutions 8K at 30 hertz, it does not like you playing at 12-bit color. That's why the screen turned yellow just now. Just knock everything back down to 8-bit and switch over to RGB. And you're good to go. But yeah, it will work. It will totally work, and it'll look totally fine. Yeah, actually, you know what? Let me try this. I think the recording is not going to mess up if I do this. It shouldn't. Let me hit apply. Yep, there we go. And as you can see, I'm doing RGB limited, 8 bits per channel. And here we go, 8K, 60 hertz, hit apply. And it took, as you can see, everything is super tiny, but we are doing 8K at 60 hertz. It's the real deal. If you go here to display settings, you'll see 8K at 60 hertz. And you can zoom in, you can just adjust your zoom. It's at 450%. If we go to 100%, oh boy, everything gets super tiny. That's everything's really tiny. You can't even make out anything. But let's go back to a larger zoom, and yeah, we're at 8K right now. Okay, so I'm gonna go back to 4K. There we go. This is what we're supposed to be recording at. God, I hope this doesn't mess up the video. But yeah, this is DSR. So if you have a 4K, if you have a native 4K display, you just you just check those boxes, hit apply, and it's gonna let you get all the way up to 8K resolution, no problem. All right. Let's say you don't have a 4K display though. Let's say you have a 1080p display. If you do DSR, like I explained in the last video, it's only going to create resolutions up to 4K if you're using a 1080p display. But let's say you're a fucking mad scientist like me and you want to game at 8K on your 1080p display, like I've been doing for years. All right. It's not hard to do. You just got to create, you got to manipulate the, the EDID information. Not, no, I'm sorry. You don't have to do that. You have to manipulate the registry file for Nvidia DSR for your display in order to do it. Okay. So as you can see here, I have multiple files. I have multiple registry files here for all the televisions I gamed on. A friend of mine named Logan, another friend of mine named Mark. Um, Whenever I go over to their house and I want to show them, hey man, you want to see what 8K looks like on your 1080p display? They're like, sure. You know, I can easily do that. I go in, once I hook my computer up to their television, a registry file is going to be created within my registry for their display. I just find that file, I extract it to my desktop, and then I do some hoodoo voodoo, which I'm going to explain, and then I go ahead and I'm able to do 8K. I'm able to do 8K on their 1080p televisions or whatnot. Okay, so as you can see here, I have one for custom DSR 8K from my LG B9 and the reason why I have a custom DSR for 8K on my LG B9, even though it can already hit 8K if I just do, DSR and just flip the switches, is because I have custom resolutions in here that I put in that I want to use. Okay, I may not like feeling like using the resolutions that Nvidia decides to give me. I may want to use my own, so I put those in there, and I have um, but luckily I don't. These are interchangeable. If I use these on, I know this says B9. If I use any of these on my C9, they'll work just fine. Apparently, the C9 and the B9 use the same registry files because they're kind of basically the same television. So uh, it works just fine. I could just apply any of these from my LG. I need to change it from B9 to just LG OLED, and it'll just work for any of them. All right. Um, but yeah, let me show you how to create those. So first off, I'm going to put the link in the description of my video of how to do of this calculator. But this is a calculator called DSR Calculator. This form allows you to completely configure your DSR options, enter your preference for smoothness, how soft the image will be after downsampling, or leave it at default. Enter your native resolution and all the desired resolutions you want in DSR. You can add up to 10, but DSR will not accept more than that. So I have 10 resolutions that I have added in. You do not need the custom DSR tool to get 10 resolutions if you use this method. When you're done, press the Get Hex button, and the data you need for your registry will be generated. Copy that and replace the smooth scaling data in an exported registry file, then import. All right, and a more detailed guide can be found here. And here's another, and I think this is the detailed guide. All right, so I'm gonna link both of these in the description below, so anybody who needs them can use them. But in the meantime, you just basically go to that list I gave you on that website. Let's go ahead and pull it up right now. There it is. List of 16:9 resolutions. And yeah, you just take any resolution off this list highlighted in green that's higher than your native resolution, higher than your native display. And you just start putting them in here. You just start plugging them in. All right. You type in your native resolution. So you'll put 3840 by 2160 here. Your smoothness slider, in my case, mine is set to 30. And then after that, you just start plugging in all the custom resolutions you want here, okay? All the way up to 8K or whatever you want. And then you hit Get Hex, and it's going to give you a long string of code, and you're just going to copy and paste that into the registry file, all right? So you're probably wondering how to get to the registry file. To get to the registry files for your display, you have to go here to your Start menu, and you need to type in Registry Editor, and you can just run as administrator. And then when you do that, I already have mine is already preset to take me here, but I'll start from the top. So basically you're gonna hit the drop down for H key local machine, then you're gonna hit the drop down for system, and then current control set, hit the drop down for that, and then you're gonna hit the drop down for services. And then you're going to scroll all the way down to one that's called, I don't know how to pronounce it. It's Nvidia. It begins with an N. You got to scroll all the way down. Here it is. NVLDDMKM. I don't know what the hell this, how you pronounce this, but this one. You hit the drop down for this, and then you hit the drop down for state, and then finally drop down for display database. You can ignore the ones that say adapter and connectors. These right here are going to be all of your televisions. Um, and in case you're wondering which one's your television, if you're fortunate, it will probably be the only one on the list. If not, you'll have to do process of elimination. So like see a bunch of these say SNY Sony. These are for my Sony receiver because I probably have hooked this graphics card into multiple different jacks on my receiver. So therefore it just treats each one as a display and keeps generating files. All right. One of these is probably my OLED. I have no idea which one it is. Hopefully, the fates will be in your favor and your list will be small. But anyway, you take one and you just basically go to. Let me extend this over. You basically go to. Actually, you don't do that. I think you just right click it. Yeah, you just right click it and you hit export. Now, if you want to, if you try to hit export and it gives you an error or something, it says you don't have permission, you just go to permissions and then you go to administrators and then you hit uh, allow full control, for administrators. And then after you do that, then it will export that file to this registry file to your desktop. And then once it's on your desktop, I'm going to go into one of my registry files and show you what it looks like. We'll use we'll use um, we'll use this one. You hit edit. When you go inside this registry file, you're going to see something that says smooth scaling data equals hex. All right, the equals. Once you get past the equals, this is where you're going to hit paste. You're going to basically uh, delete whatever is past this equals out, and you're just going to hit paste. Okay, and it's going to be a long ass string. I know I could probably hit enter or something and make it shorter, but it's going to be a long ass string when it's done. And then you hit file, save, or save as, and you name it what you want. And then you just double click it. It's going to actually, you want to add this into the registry. You hit yes. You restart your computer, and when your computer comes back on, you will have all the custom DSR factors you input. It will be right in here, all the way up to 8K. Okay, so that's how you do that. So that if you're on a 1080p television, you can turn that 1080p TV to a 4K or 8K or 5K display right now. You don't have to go run out and buy a new television. And then you can go look at some nice 4K or 8K content on the internet and see how that looks on your TV. All right. But once again, the best and most clearest quality you're going to get is always going to be through custom resolutions, using custom resolutions. Custom resolutions look far clearer and more genuine to what that native 4K, 5K, or 8K image is, because it's using the scaler on your television, which, let's face it, your television knows how it knows what it likes. It knows how good an image should look versus your graphics card versus your graphics card suggests. Okay. Anyway, so yeah, I hope my instructions were clear. If not, once again, as always, leave me feedback, leave me advice. If you need me to if you want me to do some videos to show you how some of these games can run or look or handle themselves, I have Rivatuna Statistics Server. I can turn that thing on. It will show you how my system is performing, handling these resolutions. I'll make some videos for you guys showing you how playing at these lower resolutions such as 1080p, 1440p, whatever these two are, how they look being upscaled back to 4K. So if you can get an idea if that's something you want to do. And that's it, man. That's all I got. So hopefully this video is a lot shorter than the last one I did. Anyway, fellas, be safe. Hit me up once again if you have any questions. Give me feedback. Thumbs down, thumbs up. I don't care. And you know me. I don't sit there and ask nobody to be no subscribers to me, bro. I'm just here to share some information. So if you like the content, let me know and tell me what you want me to fix or do improve upon or add more videos of. Okay? Take care, guys. I am out of here.